Hi, grade 10. So just looking through your evidence, it seems that question 5 was tricky for a lot of you. So I'll just go through these again so that you can see if they make sense and how you would solve them. So I think I did 5A already for you, but I'll just go through them all again anyway, just in case, because I think the live video broke down and you didn't get access to it. So first one was sine x plus cos x all squared equals 1. So as I said before, you choose one of the sides that you're going to prove. So in this case, I'm going to prove that the left hand side is equal to the right hand side. So I'm going to prove the left hand side. So by doing this, well, sine x plus cos x squared, well, expanding that bracket, I'm going to get sine x squared plus 2 sine x cos x plus cos x squared. So again, I'm not rearranging this. This is not solving an equation. Essentially, for any value of x, these two should be equivalent on both sides. So you're not solving the equation, you're proving the identity. So do not rearrange. I'm only proving the left-hand side is equivalent to the right-hand side. So here, if I was to rearrange this, you can see that I've got sine squared x and cos squared x. Well, we know that trig identity, sine squared x plus cos squared x is equal to 1. So 1. And we know that 2 sine x cos x is equal to sine 2x. So by knowing those trig identities, you've got sine squared x plus cos squared x is equal to 1, and we know that 2 sine x cos x is equal to sine 2x, therefore proved. Okay, so the first one starts off quite easy. B, we've got 1 over cos theta is equal to sine theta tan theta plus cos theta. So this one I'm going to prove the right hand side is equal to the left hand side, equivalent. So sine theta, and I'm going to change tan theta into sine theta over cos theta plus cos theta. So I'm going to end up with sine squared theta over cos theta plus, and then I'm going to make that a common denominator, so I'm going to change that to cos squared theta over cos theta. So now I have a common denominator, which I'm going to just put over here, cos theta, and then I've got sine squared theta plus cos squared theta. And then again, using the same identity we used before, you've got sine squared theta plus cos squared theta. We know that this is equal to 1. So therefore, 1 over cos theta. And hence, the left-hand side is equal to the right-hand side. This one was the left-hand side was equal to right-hand side. I did the right-hand side for B. Okay, we'll keep going. So C, I think I did for you as well. So this one looks a lot trickier. It's 1 minus cos squared 2x over 2 sine x cos x is equal to 2 sine x cos x. So if you remember in this one, you got to remember your double angle rules. So I'm going to prove the left hand side this time. So by doing that, I can state that 2 sine x cos x is equal to sine 2x. And then also, if you remember the identity which says sine squared x plus cos squared x equals 1. So if I rearrange that, sine squared x is equal to 1 minus cos squared x. So in essence, sine squared 2x is equal to 1 minus cos squared 2x. So I can replace the numerator with sine squared 2x. And then, if you remember simple rules of algebra, if I've got a squared on the top and a on the bottom, indices say that when you divide exponents, you subtract the powers. So 2 minus 1 would just become a1. So if I apply that same rule, then that's just going to leave me with sine 2x. And we know that sine 2x is equal to 2 sine x cos x. Therefore, we have proved the trig identity. I'm going to run out of space. I might have to... so now we're on to D. So I've got cos theta plus sine theta is equal to 1 minus 2 sine squared theta over cos theta minus sine theta. So what am I going to do here? Well, I'm going to use the right hand side this time. So if we remember our rules, 1 minus 2 sine squared theta, well, that's a double angle rule, which we know is equal to cos 2 theta. So I can change that to cos 2 theta. Over cos theta minus sine theta. And then we also know the other double angle rule for cos 2 theta. We can say that it's cos squared theta minus sine squared theta over cos theta minus sine theta. So that's, I'm jumping from one double angle rule, 1 minus sine 2 sine squared theta is cos 2 theta, and then cos 2 theta can also be written as cos squared theta minus sine squared theta. Now if you think about this, this is a difference of two squares. So if you remember the rule, that if I've got a squared minus b squared, I can write it as a plus b, a minus b. It's a difference of two squares. So that means I can write this as cos theta plus sine theta cos theta minus sine theta over cos theta minus sine theta. So by using difference of two square rule, I'm able to put it into double brackets. And then what can you do with your brackets? You can cancel out the numerator here with the denominator here, which therefore leaves you the left hand side, cos theta plus sine theta. So I have shown that my identity is proved. Okie doke, now we're on to the last one, which is 5e, and I have no more space, so I'm going to rub out here. So hopefully you've written that down. It's a video anyway, so all good. Shrub that out. Let's see if I've got enough space. I'll choose a different colour as well. I'm bored of blue. So this one, 5e, cos to the 4x minus sine to the 4x is equal to cos 2x. So I'm going to prove the left hand side is equivalent to the right hand side. So again, remember the rule. What is the difference of two squares? A squared minus b squared is equal to a plus b, a minus b. So that also applies if I was to say a4 minus b4 is equal to a squared plus b squared, a squared minus b squared. So that's a little trick in there. So if you double the power, so a2 becomes a4, then it goes from a to a squared, b to b squared, a to a squared, b to b squared. So hopefully that makes sense. So what I can write here is cos 2x plus sine 2x bracket cos 2x minus sine 2x. And then we know from our very basic trig identity that cos squared x plus sine squared x is equal to 1. And we also know that our double angle rule says that cos squared x minus sine squared x is equal to cos 2x. Therefore, 1 times cos 2x is cos 2x. Therefore, left hand side is equivalent to right hand side. Identity proved. Hope this video helps you all. Peace out.